picking up in lesson 5.6 where we left off yesterday. Sound good? If you recall, we were talking about law of cosines. We had 3 different variations of law of cosines up top, right? And we were working in example 1. I had drawn my triangle, and we had found side C. Because when they give us sides A and B and angle C, that's the only place we can start, is to find side C. And we were getting ready to move on. And then the bell rang. So, at this point, we have found side C, if you will. We still have to find angles A and angles B. Angle A and angle B. There we go. We know sides ABC, and we know angle C. What do you want to find and how? Okay, that's true. In this class, we had the discussion of, could we go law of sines now? Technically, yes, you could go law of sines. And it should, occasionally law of sines versus law of cosines will give you a slightly different rounded answer occasionally. But generally, it works. For my lesson purposes, we need to practice some law of cosines. Okay? Now, what'd you say? Well, that's at this point, we have to find angles A and angle B. So we either have to use the formula that uses cosine A and find angle A, or we have to use the formula that uses cosine B and find angle B. Well, officially, we could do either of these. We could do A squared or B squared, because we have all of them. Now, it matters which you tell me to start with here. It does matter whether we start with angle A or angle B.
Well, we know the side for angle A, right? So we also know the side for angle B, but just because it's like the unrounded version,
as much as I would love to say, let's avoid using C because it is a rounded, as opposed to A and B, which are accurate, we're going to have to use all the sides. What I need you to go up and recall is, and this was yesterday, so you've slept since then, what I underlined right here. You always, when using law of cosines, want to find the smallest angles first. So out of A and B, which one is going to be the smaller angle? B. Because B is going to be opposite side 5, as opposed to A that's going to be opposite side 11. So we need to find B first. Otherwise, if you try and find A here using law of cosines, or even possibly law of sines, I'm not sure if that one would work or not, we're going to get an acute angle instead of an obtuse for A, because A is going to end up being obtuse. So I'm going to set up, so we're using since we're trying to find B, we're going to use the B equation, right? Which, to me, the B equation is the one that starts with B squared and has cosine B in it. And we're doing this because it is the smaller angle. So I'm going to write out B squared equals A squared plus C squared minus 2AC cosine of angle B. Fill in what you know. So we're going to fill in B squared, so 5 squared equals 11 squared plus 6.5 squared minus 2 times 11 times 6.5 times cosine of B. And that was obviously me just filling in all the little details, right? Okay. There's a little bit of work we need to do before we can technically grab the calculators, right? Let's go ahead and get some of these numbers, and then we'll talk about what to do. 5 squared is 25 equals 11 squared, 121. 6.5 squared, 42.25 minus, go ahead and multiply 2 times 11 times 6.5, if you will. $143 cosine B. Okay. We can do this a couple of different ways.
We could just plug it in.
We can't plug in anything yet. We can't plug in anything because I don't have an equation that says B equals.
No, we need to place 143 cosine B on the left side, and then because it's just
Essentially what has to happen is this cosine B has to become by itself, right? And yes, eventually we are going to use inverse. Because if it's cosine B, to get B by itself, we're going to have to use inverse. But we can't do it yet because we have to get cosine B by itself. Now, there are lots of different ways that could look like. Okay? If we, I don't know, you can add these two together first if you want, and then we can subtract it over. So if I go ahead and add those two together, I still have 25 equals. And again, we all have to, find ways to make this work. 121 plus 42.25 is going to be 163.25 minus 143 cosine B. I know Hansa talked about taking the cosine B to the left. I'm just going to leave actually the minus 143 cosine B here and subtract the 163.25 over. Does that make sense? So if I subtract that over, what is 25 minus the 163.25? Negative 138.25. That is equal to negative 143 times cosine B. Yes. I subtracted over the 163.25. And realize that 143 is attached to the cosine B still, right? So it doesn't add or subtract with everything else. How do I work to get cosine B by itself? Divide. Yeah, we're going to take this negative 138.25 and divide it by negative 143. Now, what's a negative divided by a negative? Positive. For the moment, and I don't care how you guys do this on your calculator or whatever, I'm going to write that cosine B equals 138.25 divided by 143. Because that's probably some decimal, and I don't want to write the decimal down right now. I'd rather just write that fraction. Now, what do I do to finish this then? If I have cosine B equals this fraction. Okay, so B, angle B is going to equal cosine inverse of what I have written as the fraction 138.25 over 143. Grab the calculator, do the math if you haven't. She says 14.8. For those of you that, let's see. I'm just going to put it right up here. And that is 14.8 degrees, yes? Okay. That was angle B. How are you finding angle A then? Because that's what we have left. all three angles add to equal 180 in a triangle, right? You could do law of cosines using, actually no, you can't do law of cosines. Sorry, if you do law of cosines, you're still going to get the wrong angle. You need to use the 180. Angle A plus angle B plus angle C equals 180. A plus 14.8 plus 20 equals 180. Angle C was 20. I was just writing down my given. Ah, okay.
Oh, side C was 6.5.
Yeah, no, I put 6.5. I was like, what are you talking about?
Oh, that would be side C. That
So
was
I
not
don't know what
angle.
your capitals and your lowercase are.
With C's, it is impossible to tell between
because
capital
they're
and lowercase.
exactly the
And
same.
that is why I try to, when I give answers, and I didn't here with B, I try to put an angle sign in front of the angles. I don't always, though. Okay, what'd you guys get for angle A? 145.2 degrees. Okay. Get what you need there. That is a little bit about how law of cosines works. You've seen both variations of law of cosine. One where you're solving for the side at the beginning, the other where you're solving for the angle. You're always going to be solving for the angle or the side at the beginning there or the end. So, okay. Ready to try an example with side, side, side? That previous one was side, angle, side. Now we've got a couple examples to try with side, side, side. Example A, solve triangle ABC given that A is 7.7, B is 4.5, and C is 19.5.
You can pretty much find whatever angle you want.
No, you just showed
Okay. Officially, we'd have to start with the smallest.
Oh, that's fine.
Now, I will say, when they give you three sides, before you start finding your first angle, you need to double check something. If it's an actual triangle. So there was a starred comment up at the top yesterday. Two sides must add to be bigger than the third side. So on a situation where you're given side, 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 you need to double check that before you begin and waste time.
no, 1.2 is smaller than 19.5.
We're getting the not out of the way right away.
I was sitting here working ahead, trying to figure out why the calculator was saying here.
Oh, yeah.
I wondered how many people were working ahead and getting caught here.
Already put 12.2.
Okay, so in this case, A and B are the smaller sides.
Yeah.
They, in order to make this a triangle, A plus B has to add to be greater than C, because the two smaller sides have to add to be bigger than the longest side. 7.7 plus 4.5 then needs to be greater than 19.5. But that means our statement says 12.2 is greater than 19.5. Is that true?
No.
No, that's not a true statement. So,
No.
this is not a triangle.
That's it. I thought you were going to be like, well, now you have to make it bigger. We'll have to-
You can't change the given information.
Yeah.
We can't get that fancy. This is not a triangle, and I'm going to write on here so you know. Two smaller sides must have a sum larger than the third side, or however you want to write your explanation. So that when you look back at this later and you're thinking, why was this not a triangle? You know why it wasn't a triangle. Are we good on that one? Easiest problem of the day, right? It's only the easiest problem, though, if you catch it before we get started. Otherwise, you're like Ross, who's back there doing all this work and can't figure out why it doesn't work out. Now, the thing is, you were getting errors on your calculator, Ross. Is that what was happening? When you tried to do like cosine inverse and cosine and stuff? And that is the key, guys, is that if you get an error, that does not necessarily mean it's not a triangle, but it does mean that could be a possibility. Okay, so go back and check things. Don't just assume it. Okay, let's try B then. Solve triangle ABC, given that A is 9, B is 7, C is 5. Stella says we have to do this one. We have to do this one because the smaller sides, 5 plus 7, add to be 12, and 12 is greater than 9. That is my quick check of, oh, yep, we have to do this one. I guess I could get zoomed out so we can actually see this. Okay, we're given 3 sides. Which angle should we find first to be safe? C. And technically, you could probably find either of the 2 smaller angles first. Just don't try and find the largest angle first. That's the one that will get you into trouble. If it's obtuse, that is. Okay? So, if we're going to find angle C, we're going to be using the equation that reads C squared equals A squared plus B squared minus 2AB cosine of C. Think you know what to do here? Let's see. 5 squared equals 9 squared plus 7 squared minus 2 times 9 times 7 times cosine of C. I'm going to do some math, mental math here. 25 equals 81 plus 49 minus 126 cosine C. Did my mental math do good? Yes. And again, at some point we're going to go different directions about which steps you do next and how, I would go ahead and add 81 and 49. You wouldn't have to, though. You could go ahead and subtract them over. 81 plus 49 is 130. Still minus 126 cosine C. If you haven't started moving stuff over, what has to happen at this point? You're subtracting the 130 over to the other side, aren't you? 25 minus 130 is negative 105 equals negative 126 cosine C. Okay. Get cosine C by itself. So we're going to divide the negative 105 divided by negative 126. And you're always going to see me. It's going to happen like this every time where it's going to be a negative divided by a negative. And a negative divided by a negative is automatically a positive. Right. Right, which is why this is always going to work out to be negatives. So I'm going to write this as cosine of angle C is 105 divided by 126. In order to find angle C here, we have to inverse. So C is going to be cosine inverse of 105 over 126. I agree with the 33.6. Do I need to do this in my calculator? Are you guys all trying it and it's working for you? Or you're confident that when you put it in on your own later it's going to work?
I kept putting sine instead of cosine into the calculator, and I'm like, there's something wrong with it.
And that's where, if you can't figure out what is going on wrong, please ask. Obviously, it sounds like you got it figured out before you got to me, but yes, please ask, because I will gladly help calculator troubleshoot.
The smallest angle first, and I found the C and then B, and B was smaller, and I'm like, how?
Okay. That valid issue. Okay. What should we do next? B is our next smallest, and we're going to use the B squared equation, right? B squared equals A squared plus C squared minus 2AC cosine of B. And as I said, whether you find C or B first technically doesn't matter in this situation. It's just don't find A using law of cosines. Okay. 7 squared equals 9 squared plus 5 squared minus 2 times 9 times 5 times cosine of angle B. Can I just keep going on this part? You guys kind of have an idea of what you're doing here. 49 is equal to 81 plus 25 minus 90 cosine B. If I go ahead and add my 81 and 25, 106 minus 90 cosine B. I'm going to agree to 106 because that's what my mental math had told me, but. And then, personally, I would suggest subtracting the 106 over. I'm sure some of you have already found shortcuts of ways you like to do it, so that works. 49 minus 106, negative 57, equals negative 90 cosine B. To get cosine B by itself, we're going to divide the negative 90 away. So negative 57 divided by negative 90 is really positive 57 divided by positive 90. And if it says cosine B equals, we're going to do cosine inverse of 57 over 90. And angle B according to my notes and according to Stella, 50.7 degrees. And how do I have to finish this off? Angle A plus angle B plus angle C equals 180. So with that in mind, what is angle A going to be? Sorry, what was it? 95.7. Okay, get what you need from there. And you can flip to example 3 and start thinking about a baseball diamond. Excuse me. All right. Example 3. The bases on a baseball diamond are 90 feet apart. The front edge of the pitcher's mound is 60.5 feet from the back corner of home plate. Find the distance from the center of the front edge of the pitcher's mound to the far corner of first base. Okay, there's what we're going to call my baseball diamond. You're going to deal with it, right? Right here is my home plate. And then that means my first base is over there, yes? And then we have a pitcher's mound in here somewhere. Here's my pitcher's mound. Now, it specifically says the bases on a baseball diamond are 90 feet apart. So that means the distance from home to first is 90 feet. The front edge of the pitcher's mound is 60.5 feet from the back corner of home plate. So that means this distance right here, right, is 60.5 feet. At least based on this particular pitcher's mound, right? Find the distance from the center of the front edge of the pitcher's mound, so right here, to the far corner of first base. Meaning, what did I just draw here? A triangle. And what you have to realize, this is not necessarily a right triangle. Pitcher's mound is not necessarily directly out from first, directly on the line between first and third. Okay? If it was directly, guaranteed directly on the line between first and third, then, you've got yourself a right triangle. This is not necessarily a right triangle. Okay? Now, my recommendation, because we're going to have to pick a formula to use, right? Obviously, this is a law of cosines word problem. My recommendation is that we put some labels on here so we know a little bit about this problem, or so we can set it up. Okay? I don't know that it really matters. I'm doing A is home, pitcher's mound is B, first base is C. If that's the case, that means I'm trying to find side A. I know that side B is 90 feet, and I know side C is 60.5 feet. One other piece of information you have to observe here. In order to find side A, using this setup, we have to have a side angle side setup. What do you think angle A is? What? 45? Half of a 90-degree angle? So even though we don't know pitcher mound placement in relation to first and third, at each base and at home plate, they are 90-degree angles on a baseball field, yes? The pitcher's mound is directly in front of home plate, and if that is coming down here and bisecting this 90-degree angle, that means each side of this is 45 degrees. Can I sell you on that? And from here, you can do some law of cosines. We haven't done this type of law of cosine since the beginning of class yesterday, so it's a good review. I'm going to use the equation since I'm trying to find side A that starts a squared. A squared equals b squared plus c squared minus 2bc cosine of angle A. A squared is equal to 90 squared plus 60.5 squared minus 2 times 90 times 60.5 cosine of 45 degrees. Okay. You can start doing simplifying pieces right there. Or technically, you could plug that whole line into your calculator, couldn't you?
Yeah, that's what it was.
Okay. You could start doing simplifying pieces here. Like you could go ahead and do 90 squared, and you could go ahead and do 60.5 squared. You could go ahead and add those. You could go ahead and do 2 times 90 times 60.5. But say what now? You can go, yes, you can go ahead and plug that in. The only key is that after we plug it in, we're still going to have to do the square root. Now, how fancy, I mean, you can get pretty fancy here and go ahead and plug it in. But I can go ahead and do 90 squared plus 60.5 squared minus 2 times 90 times 60.5 times cosine of 45. So I'm just plugging it all in. So A squared is equal to 4,059.8571, yada, yada, yada. But then I still have to do the square root, right? So when I do the square root, I end up with A is approximately 63.7 feet.
Now we could do law of sine being
You could not have done law of sines because you never have a side and an angle opposite each other.
now we can.
If you need to find more pieces, but we're done and moving on to the next problem.
Oh, we just needed to find the distance.
Yep, we just need the distance from the pitcher's mound to first base. So I'm quitting and moving on. So I have 2 problems in under 10 minutes. Got to move. Okay. Law of cosines. Done. You got it, I hope. We have 2 other small formulas we're throwing in at you today. Okay. First of all, this first formula is for area of a triangle. Let me point out that this capital A here is area. Okay. That is area is equal to 1/2 times side A times side B times sine of angle C. And this works given a side angle side setup. Okay? Now, keep in mind, I'll throw in right here, you could also have the equivalent setups where you could have the area is 1/2 times AC times the sine of B. Or you could have area is 1/2 times BC times the sine of A. In other words, it's always 2 sides and the angle in the middle. That's what you have to know for this to work. Now, this is find the area of a regular octagon inscribed in a circle of radius 9 inches. Let's see. I'm going to go with I'm going to attempt to draw an octagon. An octagon has 8 sides. So I draw my 4 outside sides. And then I try and connect them with the diagonals. Not the best octagon, but you get the idea. If the octagon is inscribed in the circle. That means the circle goes around the edges, right? And again, no! Easier said than done to show. I already hit the button. I missed. Okay. Radius of the circle. Okay. And so radius of the circle is 9. That also means my circle touches. There's a whole bunch of radii here, right? It touches at each vertex of the octagon. Does that make sense? Like we can divide this into 8 pizza pieces, if you will. If pizza is a good way to refer to that. The area of the regular octagon. What do we have here? We have 8 pizza pieces. So we're going to do 8 triangles. Does that make sense? In order to do one of these triangles, we already know that they have sides that are how long? 9 and 9. Okay.
So wait, like you're saying sides of...
The sides of the triangle. The radius of the circle is the side of the triangle, and it's 9.
And we know the angle at the center, because altogether it has 360 and we have 8 triangles.
Okay. So right here, this angle in the middle. A circle is 360 degrees, right? 360 degrees divided by 8 is 45 degrees. So that angle in the middle, in between the 2 9s, is 45 degrees. Do I have a side angle side setup? Yeah. So I can use that area formula earlier. It's 1/2 AC sine B or 1/2 AB sine C. The idea is it's a side angle side. So my 2 sides are, don't forget the 1/2 that I just forgot. So 1/2 times 9 times 9 times the sides, and then what's the angle in between them? 45. So sine of 45 degrees. That's going to give me 1 triangle. How many triangles do I need? 8. So you punch that all in your calculator, 1/2 times 9 times 9 times sine of 45, get that answer, and then you need 8 of them, so multiply by 8. And we end up with an area of, I have 229 inches squared written down as my answer. Don't ask me why I went whole number, that's what I have. It's area, so it's inches squared. Okay, guys, I got one more answer problem I got to get in. We have one other formula for you. This is Heron's formula. Heron's formula uses side, side, side. If you know all 3 sides of a triangle, you can find the area. So right here, we have an area formula. When it says big A equals, that A stands for area. Now, you also have to pay attention to here. You have to be able to find something called S, which S is the semi-perimeter. It's the distance around the triangle divided by 2. So when it says S in this formula, side A plus side B plus side C, all divided by 2. This is called the semi-perimeter. When we go to do this area formula, notice, what do you have to know? S, which you just were given a formula for, side A, side B, side C. So in example 5, it says find the area with sides 13, 15, and 18, yes? So 13, 15, 18 are my ABC. In order to find my semi-perimeter, or my S, I do A plus B plus C divided by 2. Well, that means I'm doing 13 plus 15 plus 18 divided by 2, and S works out to be 23. So fill in your formula. Area equals. Notice it is the square root of all that fun stuff. S. 23. Parentheses. S minus A. 23 minus 13. Parentheses. S minus B. 23 minus 15. Parentheses. S minus C. 23 minus 18. Give me just a moment, please. You can punch that into your calculator. You can do work. I will tell you the answer comes up to be 96 square units. A yay must mean you're ahead of me and it worked. Okay. Your homework that yes is due tomorrow. Page 448, 2 through 28 evens, 31 and 32. Okay?
So was that 31 that he's gonna watch too?
Probably. I don't remember exactly. Okay, guys. Homework due tomorrow. Have a good day. Thank you for bearing with me through the rush of Heron's formula. And it was a rush.
I would actually say that.
Okay, hold on a second.
You're like,